Assembly for Google Assistant controlling one LED. Components required: NodeMCU voltage regulator, one LED, one 220 ohm resistor, 9-volt battery, battery snapper, USB cable, and a breadboard. First, we will place the voltage regulator on the breadboard. Then we will place the LED. Then take some jumper wire. Connect the positive of the LED to pin D2 of the NodeMCU. On the negative, connect the 220 ohm resistor and take a wire and connect the other terminal of the resistor to the ground pin of the NodeMCU. Now take the battery snapper, connect the red wire, that is the positive, to the VIN of the voltage regulator and the black wire to the ground pin of the voltage regulator, and take another wire, connect the Vout pin to the VIN pin of the NodeMCU and the ground pin of the NodeMCU. So in this way we can power the NodeMCU with the help of a battery, but if we don't want to do that, then we can remove the wires, keep it separate, and take the USB cable, connect its one terminal to the laptop and the other terminal to the NodeMCU, and in that way we can power the NodeMCU through the your device. Thank you. Add drop fruit, IO, then click enter. So now click on the first link where you have to give your details, and then click on create account, and then you will have to sign in. And here you have to click on IO and then click on Feeds. Under Feeds you have to click on New Feed. Then we have to give a name. For example, here we will give the name as like LED and then click on create. I already have a feed name as LED, so I will change the name as LED1. You can see I have created this feed LED1. Now we will click on this API key to get our username and AI key. So you can see this is the username and Adafruit IO key. So that's all for the Adafruit. We have to copy this part as we will require this during our coding. So this part is done. Now we will create the templates in the IFTTT. So for that, in Google type IFTTT, click on the first link. You have to click on login, then continue with Google, and then you create an account. And after you have created an account, click on login. After you have logged in, click on create, then click on if this add option and search for Google Assistant. So we have added the Google Assistant. Now we have to click on the activate scene and connect. Give the scene name like turn on LED. Turn on the LED. and then click on create trigger, and then so it is done. Then click on the add on then that, and here type Adafruit. Select the Adafruit and then click on send data to Adafruit IO. Select the feed. In the feed name we have created this one, and here you type as on, and then click on create action. Now we will create one more applet. So this is one applet that we have created for turning on. Now we will, so now if you click on my applets, you will able to see we have created one applet, and we can create one more. To create the second applet we have to do the same steps. So click on create, click on add, select Google Assistant, then click on activate scene. Here give the scene name as turn off the LED, then click on create trigger, click on then that, add on the then that. Here you select Adafruit, then select the feed LED1, click on data to save as off, and then click on create action. So here you click on finish. So you have created two applets. Now if you see on my applets, you will be able to see two applets. One is to turn on and one is to turn off. In both the cases, so after doing the configuration of the Adafruit and IFTTT, we will do the coding. So before we start the coding, we have to include the Adafruit MQTT library. So for that, click on sketch and there include library, click on manage libraries. Here you type Adafruit MQTT and install this Adafruit MQTT library by clicking on the select version and then click on the install option. Your library will be installed. Once it is done, now when you will click on sketch and then include library, you will be able to see the Adafruit MQTT library here. So once this is done, now we will start the coding. So first we have included the ESP8266 and the Adafruit library. So the ESP8266 will connect our NodeMCU to the Wi-Fi, and the Adafruit library will handle the communication of the NodeMCU with the Adafruit IO over MQTT. And then we have given our Wi-Fi name and Wi-Fi password. And after that we have given the Adafruit credential from the API key in the Adafruit website. Then we have declared the LED pin. Now we have given Wi-Fi client, Adafruit MQTT client, Adafruit MQTT subscribe. So this will make the MQTT client that will handle the communication between our NodeMCU and the Adafruit IO. And MQTT subscribe feed name we have given here and is equal to Adafruit MQTT subscribe MQTT IO username. So this line will tell the NodeMCU to listen for message and offer on or off your LED from that particular Adafruit IO feed name as LED1. Now inside the while loop we have initialized the serial library. We have declared the LED pin as output and we have turned it off using the digital write function. Then we will check the Wi-Fi connection. So this will connect the NodeMCU to the Wi-Fi and we'll wait until it is connected. This will make the NodeMCU listen to the feed of the particular feed from the Adafruit IO. This will make sure that the NodeMCU is connected to the Adafruit IO, and Adafruit MQTT subscription will read the subscribed message. That means it will read the message from the particular LED1 feed, that whether we need to turn the LED off or on. So this will listen up to for 5 seconds for this will make the NodeMCU listen for up to 5 seconds for any new message from the Adafruit IO. If the message is from the LED1 feed, it reads the value and then it will compare it whether it is on or off, and accordingly will turn the LED on off. Now we have this function void MQTT to connect or reconnect to the Adafruit. So here it checks if the NodeMCU is already connected to the MQTT or not, and then print it is connecting, and then if it is not connected, it tries to connect again after every 5 seconds, and once it is connected, it will print Adafruit IO is connected, like this. So this is all about the code. So once the code is done, you click on the tools, select the NodeMCU board, and then click on port, select the required COM port, and then click on upload. Your code will be uploaded to the NodeMCU. Output for Google Assistant controlling one LED. First of all, open the Google Home app. In the Google Home app, press on the voice button and say turn on LED. Activate turn on LED. As you can see, the LED turned on. Now we will turn off the LED. Click on the voice button again. Activate turn off LED. The LED has turned off.